Hey there! In previous lessons, we learned the equations of uniformly accelerated motion. In this lesson, we will learn how these equations can be applied to something we experience every day, and that is gravity. What do you think would happen if gravitational force ceased to exist? Yes, everything would be in disarray, and the only good thing would be that you could jump off any building and float in midair like an astronaut in space. Thankfully, we have gravity, which impacts all motion in kinematics. Kinematics refers to the study of how objects move without discussing the forces that cause these objects to move. But note that all forms of motion we've learned so far are affected by gravity, but it only becomes obvious when the motion is in a vertical direction. That is, gravity can be ignored except when the motion is vertical or has a vertical component. This leaves two cases of motion under gravity: the motion of an object moving up vertically against gravity, and the motion of an object falling under gravity. Let's start with the first one. This is what you see a lot when playing with balls. You throw a ball directly up and catch it when it comes down. When you throw the ball up, you give it a push, and the ball acquires an initial velocity u. As the ball starts moving, gravity starts acting against it since it is moving in a direction opposite of gravity. So the ball experiences a negative acceleration of minus g as it moves up. At some point, this negative acceleration would have totally cancelled out the initial velocity the ball had at the beginning. And at this point, the ball stops in the air for a moment and yields to the pull of gravity. This gives the ball an accelerated motion, as the ball is now moving in the same direction as acceleration due to gravity. Since acceleration due to gravity is constant for any given location, we can use our equations of uniformly accelerated motion to solve questions on motion under gravity. When an object is moving up, it is acting against gravity, and we will replace A with minus g in our equations of uniformly accelerated motion. But when the object is moving vertically downwards towards the earth, you replace A with g in our equations of motion. And this is because it is moving in the direction of gravity. You can write these two sets of equations with plus or minus g substituted for A, with the knowledge that plus g represents the motion of an object falling vertically to the earth, and minus g is for the motion of an object going up vertically. And these are the equations of motion under gravity. The value of acceleration due to gravity on Earth is about 9.80655 meters per second squared. That means if you drop a feather and a stone from the same height, they should reach the ground at the same time because the acceleration due to gravity is constant. But does that happen in your experience? No, it doesn't. This is because of air resistance. The air resistance acting against the feather is more because of its large surface area and small density. In the absence of air resistance, both objects would reach the ground at the same time. And this was confirmed in the famous hammer feather drop experiment conducted by the astronaut David Scott in 1971 on the surface of the moon. He dropped a hammer weighing about 1.32 kilograms and a 0.03 kilogram feather from a height of approximately 1.6 meters. Both objects were observed to descend in step and hit the lunar surface at the same time. So you can blame gravity next time you fall. Stay safe.